Good morning, everyone, or good afternoon. Thank you for joining us. We're just going to give it a couple minutes as more people kind of join in this morning. Where's everyone chiming in from today? It's going to give another minute. Oh, Austin, Texas, Massachusetts, Toronto. Awesome. Well, as everyone's joining in, I just want to thank you for joining the Dell and Red Hat Strengthening Cloud and Container Security Community Hour. Elevate is an independent, customer-led user group, Dell Technologies customers on the multi-cloud journey to modernizing their IT infrastructure. We bring customers, partners, employees together to share best practices and network with the industry experts at a virtual and in-person events throughout the year. If you have any questions for our speakers today, please submit that through the Q&A function or in the chat. Our host today's webcast is Ian Jones. He's the cloud infrastructure product owner at NatWest and director of the Elevate User Group Board of Directors. Ian, I'm going to pass it on over to you to get started with our guest speakers. Thank you so much.
Thanks, Gabby, for the intro. I guess I'm here to take us through the March Community Hour. And as Gabby's just said, it's strengthening cloud and container security. We've got a number of experts with us today from both Dell and Red Hat. Let me introduce them to you. So we've got Joanne Kent. She's product manager for Apex Cloud Platform Security at Dell Technologies. We've got Michael Wells, technical marketing engineer, Apex Cloud Platform for Red Hat OpenShift, and again, Dell Technologies. And finally, we've got Doran Caspin, senior manager of product management, Red Hat Advanced Cluster Security. So I'm going to hand over to Joanne to start us off, who's going to take us through security at a high level in the cloud. Over to you, Joanne.
All right, thank you very much. Appreciate it. So, hello, everyone. As mentioned, my name is Joanne Kent, and I am the security product manager for the Dell Technologies multi-cloud portfolio, which includes the Apex Cloud platform for Red Hat OpenShift. Now, I know that today's topic is about strengthening cloud and container security, and I'm going to kick off our discussion with insight into the security of the infrastructure on which the cloud and containers run. Specifically, I'm going to give you a brief high-level overview of how Dell leverages the principles of zero trust and defense in depth to provide that foundational security in ACP Red Hat OpenShift. Now, zero trust can be summarized as never trust, always verify. And while this is a catchy phrase, it doesn't reflect the complexity of implementation. Zero trust requires continuous verification of every user and device before granting access to resources, regardless of their location or network permissions. Now, defense in depth involves implementing multiple layers of security controls to create a robust defense against potential attacks. This layered approach ensures that if even one security measure fails, others are in place for a fallback to protect the system. Now, a good place to start to begin investigating how we leverage defense in depth is to consider the life cycle of a product and how each step is secured. Building in security starts long before the first motherboard is created or the first line of code is written, and continues all the way through until the final decommissioning. Good infrastructure ensures security at every step of the life cycle, and this holistic approach is fundamental to Dell's product development. So let's start with the first step in the life cycle, which is production. At Dell, our factories are fortified with multiple layers of security controls. We cover everything from informational and personnel security to physical security. This scope includes secure networks, thorough pre-employment screening, ongoing security awareness programs, and alignment with industry physical security standards. The next concern in production is supply chain integrity. And when it comes to hardware, we kick off right at the beginning of our Dell supply chain. We have robust quality control processes in place to minimize the risk of counterfeit components sneaking in. And these controls are embedded within our factory processes and align with ISO 9001 certification. For software and firmware, our supply chain security revolves around our secure development lifecycle. This process aligns with industry standards like Safe Code guidelines, ISO 27034, and NIST's Secure Software Development Framework. By paying close attention to security from the very start of the supply chain, we help minimize the risk of zero-day vulnerabilities. Now, the next step in our product's journey is getting it from our factory to the customer site, whether it's through physical shipment or downloading software from our network. The main risk here, of course, is physical or virtual man-in-the-middle attacks. Dell's sophisticated logistical programs keep a close watch on products during shipping with monitoring and device tracking. Once the product reaches its destination, customers can use Dell PowerEdge's secure component verifications, cryptographically signed manifests to validate the integrity of the installed components. Similarly, we can furnish H-bombs and S-bombs to our customers for a review of what's in the product they purchased. For software and firmware, all cryptographically signed downloads are accessed through authenticated and secure Dell IT networks to reduce the risk of unauthorized modifications. Now, once the product is on site, it's time to set up and deploy for long-term maintenance. So let's start with the silicon or hardware root of trust security control, which is established actually in the factory. It allows for on-site authentication of server and storage booting and firmware updates. With root of trust, read-only cryptographic keys are burned into the silicon microchips of the processors used in Dell designs so that they cannot be altered or erased. At power on, the processor verifies that the BIOS code is legit, significantly reducing the risk of undetected BIOS modification and pre-boot malware. Similarly, Dell's software deployment and upgrade packages, digital signatures can be validated manually or automatically using UEFI Secure Boot. Now, during deployment, ACP Red Hat OpenShift leverages the onboard TPM to enable data at rest encryption on the boot device for compute nodes. Additionally, the deployment process defaults to FIPS-only mode, ensuring cryptographic operations are limited to those formally approved by NIST. Now, customers can choose to opt out of FIPS-only mode if needed. As we all know, limiting the crypto set can affect older applications running on this system. Please note, though, the choice of FIPS-only or not is a one-time action, and to revert, the entire system needs to be brought back to factory settings and completely redeployed. So choose wisely. Wrapping up the product lifecycle is the decommissioning phase. Now, most steps involved in decommissioning are a part of the customer's own processes. And what needs to be done depends on whether the product will be repurposed or completely taken out of service. But regardless of the path chosen, it is crucial to ensure that the customer's data is eliminated before the final steps are taken. So for that, ACP Red Hat OpenShift supports Dell PowerEdge's System Erase and Secure Erase features. System Erase makes it easier to wipe server storage devices and non-volatile stores like caches and logs. Secure Erase removes sensitive data and settings from the server and can cryptographically dispose of data on any SEDs, ISE drives, and NVM devices. Now, so far, we've been focusing on the deep layered security throughout a product's lifecycle, making sure it's created, shipped, deployed, and maintained as securely as possible. Let's explore now the core zero trust security control, identity, and access management. IAM centers around ensuring that any entity attempting to access any dimension or layer of a product is known, valid, allowed, and tracked through authentication, authorization, and auditing. Now, authentication can be tricky in larger data centers where users might be challenged multiple times and they struggle with remembering individual passwords, while administrators have to deal with the daunting task of managing users of disparate deployments, which often don't work well together. Modern data centers, of course, tackle these issues with SSO, using an identity provider to simplify authentication and add on security controls like MFA. ACP Red Hat OpenShift leverages authentication and SSO through OpenShift itself, which supports multiple identity providers, offering a broad set of options for our customers. For authorizing access to a requested resource, we rely on OpenShift's built-in RBAC features. And for tracking, we leverage OpenShift's rich auditing feature set, which includes the ability to integrate with popular SIEM systems. A critical component of both Zero Trust and Defense in Depth is keeping data on the system safe with encryption. ACP Red Hat OpenShift offers features to support each of the basic types of encryption: at rest, in flight, and in use. Data can be encrypted at rest on compute nodes by opting for an encrypted boss boot device. It's encrypted in flight with TLS and protected while in use via OpenShift's leveraging of secure enclaves through Intel Secure Guard extensions and AMD's Memory Guard features. ACP Red Hat OpenShift supports these capabilities with built-in certificate management, the onboard TPM, and as mentioned earlier, the ability to deploy in FIPS-only mode. Now, finally, on top of everything else, ACP Red Hat OpenShift comes with the service mesh. This feature provides mutual TLS to encrypt and protect communications between microservices. It also offers the ability to automatically rotate MTLS certs, configure service RBAC and authorization policies, and manage API traffic, which can be leveraged to define which services are allowed to communicate. Dell and ACP Red Hat OpenShift prioritize security by aligning with the principles of Zero Trust and Defense in Depth to provide a secure hardware and software security foundation. I hope this interview gives you a clear idea of our commitment and approach to infrastructure security. And if there aren't any questions, I will now release you to discuss container security with Duran.
And I guess just a reminder to post any questions you've got in the Q&A section, so we can pick them up as we go through. Over to you, Joran.
Thank you, Ian. Great presentation. And so let's dive into the OpenShift side, or the product security of the containers running on OpenShift. Not just container, now OpenShift also running virtualization and virtual machines. Next slide, please. As part of our philosophy that we believe in a full cycle security, that security is continuous and holistic, that we need to discover security in all the phases of the development, even on design phase. When we build a product, the first time a developer start developing or submitting his image to a repository, and we have tools that allow you to scan for vulnerabilities and enforce policies on the development side. We also provide a trusted, so the Red Hat approach, yeah, just a little bit. Can you go back to this previous slide? So also we integrate tools for runtime security, so and have all the tools that you need to run the trusted platform, including RHEL core OS that come with OpenShift that allow you to have secure base images, secure containers, running environment, and deployment. Next slide, please. So 3 steps of security. Again, first, the infrastructure that you have running. John mentioned it on the Dell side. Again, you can run on bare metal, virtualization, public cloud, private cloud, edge, or any other combination. we have our OpenShift come with RHEL Core OS. It's a hardening version of RHEL with minimize their attack surface of the nodes, allow you to be sure that you're running on the most secure clusters on the node level. The second level is the implement trusted supply chain from the development to deploy and to the runtime. So it allows tracking SBOMs, signature, assign an image validation of signature and runtime, and also secure again vulnerability and compliance checking all the way from development to production, and also managing the automate the secure and hybrid cloud. So everything you can use automation tool. You can use GitHub for that to manage your configuration and manage the policy, and also provide automated process that provide you notification if anything wrong with the system, or we found any vulnerabilities or any policy violation in runtime. Next slide, please. OpenShift come in few flavors, and I will talk with one on a big one, on the more general one. We have our again, as I said, we have the basically everything is based on Linux. You can use SC Linux. You can use other tools to protect your environment, and also, as I said, we can come where OpenShift come with RHEL Core OS as a secure nodes. We have our Kubernetes orchestration level and Kubernetes cluster services. It's our base engine for Kubernetes, aligned with vanilla Kubernetes or our version of Kubernetes. We have a second level that called OCP, or OpenShift Container Platform, that contain the level of how we manage the workload, build and CI/CD pipelines, GitHub capabilities, log management and cost management, API management, service mesh, and other tools that we allow the customer to use on the platform. And we have the fourth level, that it's what we call OpenShift Plus, OpenShift Platform Plus, that include 4 tools. One of them is the multi-cluster management. As soon as you have more than one cluster, you want this tool to manage the Kubernetes cluster or the fleet, allow you to use observability on multi-cluster environment, discovery of clusters, policy management, compliance, configuration management, and workload management. The second capability is advanced cluster security that allow you to maintain the vulnerability posture, the network segmentation, and detect threat and respond to a threat in the runtime. We also provide Quay as a global registries, one place to manage all your registries and scan images in the registries and other tools. And we also provide the data cluster, the data foundation, allow you to manage object storage and other multi-cloud gateway for DR. Next slide, please.
Just a quick question on the, I guess that the platform. I can't see it now, but you've got the OpenShift container platform, and then you've got the one above. Is that additional sort of licenses that are required for that, or does that come with OCP itself?
So OCP itself is the second level. It's the OpenShift Container Platform. We have a smaller version called OKE that provide you the basic cluster services. If you compare it with EKS capabilities, this is okay. But most of the customers are using OCP or OCP Plus that provide the additional capabilities, because we have a lot of added value in this area.
Okay, Okay, so if you've got, you need multi-cluster, then you need to go Platform Plus. If you've got a single cluster, you can
Mostly,
just
yeah.
stay with OCP. Okay,
Yeah.
got it. Thank you.
And also, all the tools, for example, ACS or Advanced Cluster Security, also can work as a standalone on top of OKE. So OCP, you don't need you can have a mix and match here in different levels.
Marvelous. Thank you.
Thank you. Next slide, please. So let's focus a little bit on ACS, so Red Hat Advanced Cluster Security. It's our tool, Red Hat tool to provide security on Kubernetes environment. And we provide 6 major use cases: vulnerability management, security configuration management, risk profiling, network segmentation, compliance, and detection and response. For vulnerability management, we allow you to scan the vulnerability on that deploy time, on dev time, and runtime. So and also provide policy around it. So for example, you can block images from deployment if they have vulnerability on them, or they have high vulnerability, or have all kind of policies around vulnerabilities, or stop images with old vulnerabilities running on your systems. We also provide a way to see all the configuration, the Arbor configuration of the system, all the secrets that are running in the system, not the secret itself, of course, but you can see all the secrets and what deployments are using the secrets. We provide a tool for risk profiling, so you can see the most risk deployments, and based on that, handling and remediate this deployment. You can also use network segmentation, and we provide the capability to manage your network policy on OpenShift, and allow you to see the network and see communication with external networks, so see traffic. We also provide capability for scanning your cluster, and with different compliance framework, for example, CIS benchmark, NIST 853, or PCI DSS, allow you to use our tool to secure and enforce your cluster to be aligned with this standard, and also provide you best practice for securing your cluster. Also, detection and response, we provide integration with any tools that are using for incident management, for example, ServiceNow, or PagerDuty, or Jira, or Slack, or something like that. So every active threat that the policy engine detects, we have a policy engine that detects threats or detect misconfiguration. We can send a notification to the relevant people and allow them to manage it and mitigate the risks there. Next slide, please. Again, it's a little bit more information. Again, the 3 stages: the build, deploy, and runtime. Securing the supply chain for vulnerabilities and also for other issues. Deploy time, and not allow things to be deployed with security risks. And runtime, find issues on communication, and also, for example, if a container try to run a specific command in runtime, we can block it, we can notify the user, and allow you to handle this risk. We have a very powerful policy engine, but you can build your own policies and configure it, and a robust API that you can integrate with your system externally and internally. We provide integration with any registries, most popular registries out there, integration with CI/CD tools to allow you to enforce policies in runtime and in build and deploy time. We integrate with most common DevOps tools that exist out there. Integration with SIEM tools, and also provide integration with Synapse tools and CSPM. Also integration with the big cloud provider out there. I think this is my last slide. Next slide, please. Yeah, thank you. Again, if you have any questions, let's fire up on the Q&A.
So we've got one currently. So we've got one currently, if you want to answer it. So we need OPP to use ODF. So, do we need OPP to use ODF, or is it available as add-on for the other editions?
Yeah, you can have OD data foundation as an additional. No, you don't need the OPP, the full OPP for that.
Okay, great stuff. Thank you.
Thank you.
Okay, so yes, if anyone's got any questions at this point, we are here to take them. So please feel free to send them on the Q&A. I guess while we're waiting then. So I guess a general question then, maybe for the panel to answer. So what are the emerging trends in cloud and container securities that organizations should be aware of?
I think that the most common, again, it's not new, but the amount of vulnerabilities that exist out there are raising in multiply way in the last few years. I think it's because of again more issues are found by automated tools, and also the numbers of people are using Kubernetes are found more and more issues and vulnerabilities, and the way that you need to maintain this your infrastructure to be up to date, it's become harder and harder every day. And you need to update, and you need to be on the latest release of all your software for that. And again, we also see it on the laptop that you get the latest release, and always there is vulnerabilities that we need to fix and provide a fix for that. So it's one of the trends. Of course, we have the AI world that bring additional vulnerabilities to the systems. Red Hat has their own. We have our own OpenShift AI tool, and people are using different models that come from open registries like Hugging Faces. Some of them are not really validate or any way to. You don't have the way to validate that it's the model that don't have vulnerabilities. It's not just software vulnerabilities, also model vulnerabilities that are not fake models or have data poisoning. So it's the next trend in line that we need to find a way to make sure that our engineering and our teams are using models from sources that are you can rely on, and they're not using models that are just download from someplace in the internet. So,
if I could add one thing, one of the benefits of containerization is the fact that all of the dependencies that you need within an application are within that container. It's all packaged together, so it's easy to consume and deploy. But what that also means is you can have completely different versions of similar applications, libraries, in use throughout the system, which is where a tool like Advanced Cluster Security becomes really important, because it's going through and it's scanning all of these container images that you have stored within your registry, going through all of the various layers within the container to identify all of the components that are in use and any known vulnerabilities within those components. And it's also scanning those containers that are already running on the system to see the same thing and to identify if they're doing anything that's suspicious within the environment, if they have higher level permissions than they should have. So where you can see that containerization can give you this vast area that you have to manage and monitor security across, that's where a tool like ACS gives you that ability to easily see across the entire landscape what's going on.
Yeah, so what we're looking at in the cloud is just, it's a scale issue. It really is. Being able to manage your security across the full scale of the cloud. It's easy in cloud environments to lose track of when you've spun something new up and it's still out there. Is it being properly maintained? So when you're off in the cloud, it's really that scale. And it, as Jaron was talking about, it's only made worse with the AI and the AI attacks, and everything just becoming more intense. But on the flip side, what you're also seeing is using AI to fight AI, and those tools spinning up and starting to use them to protect that larger attack surface. So the trends are escalating quickly, and it's definitely something that we need to watch and find ways that we can adapt to at not only the container level and the software level, but also making sure that that infrastructure level itself remains as secure and updated as possible.
Yeah, I think I saw something yesterday that said how many vulnerabilities have been identified and how it's grown almost exponentially over sort of the last 20 years. Just really shows you why it's so important that we just keep up to date with this stuff, and it's almost getting to a point where a human it becomes unmanageable as a human, right? So we need the tools in place to be able to detect and remediate. So,
And it's easy to audit those things that you're creating in-house. But more and more, we're seeing containerization as a deployment model for organizations that don't build their own software.
Yep.
So they're consuming containers that are created by somebody else, maintained by somebody else, whether that's open source or that's closed source. It's an ISV distributing their software. So if you create it, you know what's inside of it. But if it's somebody else's container that you're consuming, it's a lot of work to go through and crack that open and identify everything that's in it. ACS is doing all of that for you in an ongoing basis, right? So it's looking to see things like um, uh, how long has that container been in existence, right? So um, as we move into more of that modern cloud application design, it becomes more important to re-roll your containers over time, right? Even if you haven't made a change to the underlying application code, chances are one of the dependencies that you're consuming has had some sort of important update or patch or security remediation, right? So you can't just say, well, I haven't updated my code, I'm not going to repackage, I'm not going to rebuild this container. They need to be rebuilt on an ongoing basis so that they can pull in all of those upstream dependencies. ACS is going to do things like it's going to show you if the container image you're using is older than a certain date and let you know that, hey, this is starting to become a greater and greater risk as this container continues to age. Maybe you should look at pulling a newer version of that container. Or if it's your own container, maybe you should look at building another version of that container. So things like that you may not think about because traditionally, oh, the application's running, it's stable, we're going to leave it there. Well, the reality of the situation is the longer that stable application continues to run, the greater the chance that there's a vulnerability that's either been disclosed or hasn't been disclosed that's a potential weak point.
And that comes back to supply chain security at every level.
Yeah. And also, again, we we all about, we try to do image verification, image signature. Again, if you, as Michael mentioned before, a lot of customers today are using third party to build images or build containers and validating images on runtime and also managing the SBOMs. It's really a critical part now of the software supply chain. Having a good requesting a SBOM or validating the SBOM and scanning the SBOM, also using a signature, and we have tools today to validate that validate the signature on runtime or deploy time, sorry, and provide this capability for your platform.
One of the other things that I don't hear touched on a lot, but I really like as a feature of ACS is so when we talk about secrets, the first rule of Kubernetes is Kubernetes secrets aren't secret, right? It's very easy to open a Kubernetes secret and see the data inside of it. So what we have to do is we have to make sure that we are permissioning those secrets as tightly as possible so that they're not getting accessed by people or applications that shouldn't access them. Well, ACS will actually audit who accesses what secrets. So you can actually see that this particular user has accessed this secret at this date and time. So you can actually see who's accessing those, which is a great tool.
Okay. So Michael, I'm just aware I've skipped over you completely a little while ago. So is there anything else that you want to add? So I appreciate we went to the Q&A a little bit early, so apologies. So
No problem at all. Then I just wanted to touch on some of the recent updates related to the Apex Cloud Platform for Red Hat OpenShift. With our latest release, we have 4.17 support. We'll be introducing 4.18 support soon. Of course, 4.18 has just come out and doesn't even have a stable channel yet. So as we get closer to that, we'll have support coming for that soon. One of the big things is flexible Z-Stream updates, which means that a particular version of the Apex Cloud Platform Foundation software is no longer tied to a specific build of OpenShift, which means that you are now free to update the OpenShift version from one build to another without impacting your supportability from Dell. The fact that we partner with Red Hat and participate in their distributed CI environment means that we're getting regular pre-release builds and we're validating our solution on their latest builds before those builds even go public. So that means that as soon as Red Hat releases a Z-Stream update, you are free to consume that update without having to wait for Dell to repackage it and distribute it to you. We have support now for 3-node clusters, which was a deployment limitation that we had in the past. So we can now do that for compact clusters. And then another big one is the upcoming release of PowerProtect Data Manager, which will be released next week. Adds support for backing up OpenShift virtualization VMs. So if you're looking at using VMs on top of OpenShift, which is an incredibly powerful tool, we now have the ability through PPDM to be able to protect those virtual machines, even if they're using raw block or file storage. So that's an important capability because not every backup solution that can back up containers on OpenShift can back up VMs on OpenShift. It's a slightly different model. And then, of course, we've got the H100 NVL support that was added with our last release of the Apex Cloud Platform for OpenShift. So those were the main things that I wanted to touch on.
excellent. So that backup capability is definitely going to be a real winner for anyone that's looking to explore alternative hypervisors.
Yeah. Well, and If you're looking at exploring an alternative hypervisor, it's a great way of doing it, and it opens up the capability. Because if you're going to have to retool for a new hypervisor, why not retool in such a way that you can modernize your processes to be able to support virtual machines, but also to seamlessly support containerized applications. So even if you're not moving to containerized applications yet, starting to modernize those processes so that you can do it in the same way that you're managing VMs becomes incredibly powerful, right? The same type of deployment mechanisms, the same management interface, the same type of tooling. And then when you get to a point where you're deploying both VMs and containers, the fact that OpenShift virtualization, that VM is a pod, means that I inherit pod to pod networking, and I can communicate with a service that's running in containers right from the virtual machine without having to go through the ingress controller. I can use service.namespace addressing to be able to access it. I don't have to expose that service outside the cluster through a route. It greatly simplifies that communication and minimizes that attack surface area that I have. So if I have an API that I've published as a service and I want to call into that from a virtual machine, I don't have to expose that API outside of the cluster to be able to do it. And plus, I can inherit all of the other capabilities through OVNK. I can do microsegmentation and all sorts of other really cool things just by having that on the same infrastructure, using the same deployment mechanisms, the same types of resources. So it's a great way to standardize and set yourself up for not just today, but also future application design and deployment.
So it's all on the same sort of PowerFlex unit that you could do that on, yeah?
PowerFlex, PowerStore, PowerMax. We support most of the Dell storage platforms. So as what we refer to as required storage, which is where the Cloud Platform Foundation software lives, that can be PowerFlex, PowerStore, or ODF. But as supplemental storage, that can be any of those. It can also be PowerMax. It can be PowerScale. We can support object scale and ECS for S3 storage. So most everything in the Dell portfolio can be accessed from ACP for OpenShift.
Excellent. It's pretty powerful. Okay, so so we've got no questions at the moment. So if anyone's got any questions, feel free to put them in. Okay, I don't think we've got any more questions.
Yeah, if we don't have any more questions, I just want to thank everyone for today, for joining us. And if you can share your feedback on today's webcast, I will leave that link in the chat now. But I also want to just thank you to our sponsors, Dell Technologies, Red Hat, and Intel, and Joanne, Ian, Michael, and Doran for joining us today. And also, don't miss out on the Red Hat Summit in Boston, Massachusetts, happening May 19th through the 22nd, 2025. And we will also be hosting a Elevate user group community on May 20th at Red Hat. So please don't miss out on that opportunity as well. Our next webcast will be held Thursday, March 27th. And so we hope to see you there. And on behalf of the Elevate User Group Board of Directors, have a great day. And thank you so much again.
Thank you.
Thank
Have
you.
a great day.
Thanks, everyone.
Bye.